Hello guys, welcome back to grade 10 mathematical lesson for Euclidean geometry, which is the last part of Euclidean geometry in grade 10. So we have got something to start, which is new to you, but it's not that new. Some of the things we have talked about in the previous lessons. So the midpoint theorem in a triangle. The midpoint theorem can be stated in the following two ways. Given these two triangles, A, B, C, where in these triangles, you are given that a line AD is equal to DB, and the line AE is equal to the line EC. Then, if you are given this information, you can come to the conclusion that DE is parallel to BC. Now, we come to this one. If you are given that this line AD is equal to the line DB, and also you are given that DE is parallel to BC, then you can come to the conclusion that AE is equal to EC, and DE is half of BC. That's how the midpoint theorem works. Now, let's have a look here on a midpoint theorem example. Given this triangle ABC, which is this one, we are also given that AD is equal to DB and AE is equal to EC. Okay, then DE is reduced to I'm sorry for that. Now, where was I? Oh, I was here. That's DE is reduced to F. There is F there. And then DB, why do they say DB is parallel to FC? This is DB. Can this be parallel? Oh, yes. We are also given that DB is parallel to FC and BC is 32 millimeters. And BC is 32 millimeters. So, okay, let me write that on the diagram. This is 32 millimeters. And then I'm given that this DB is parallel to FC. Then, okay, this is what we are given. Now, since in triangle ABC, I'm given that this is equal to this, and this is equal to this, and on the other side, this is equal to this. I can just say DE is parallel to BC, midpoint theorem. Midpoint theorem. Okay. And since this is midpoint theorem, this is the half of this. Okay, then I will have DE is equal to half of BC. Yes, and then what is BC? BC is 32 millimeters. That will give me 16 millimeters. Therefore, this is 16 millimeters. Only this portion, DE. Now, let's jump into the problems and see what are we required to find. In A, we are required to prove that DBCF is a parallelogram. What are the properties of a palm? Properties of parallelogram is that opposite sides of palm have to be parallel. So, we were given that these are parallel. So, I can just say DB is parallel to CF of FC. that was given. Okay, my answer for A will start here, and then now I will come to this part that the E is parallel to BC. What is the reason behind that? It is midpoint theorem. Therefore, DBCF is a palm since opposite sides of a palm must be parallel. Yes. So now we have proven that. Now let's go to the following one, which is B. We are required to find the length of the E, of which we already did when we were doing our analysis. So it is very important to just do the analysis from what you are given, and some of the questions will be answered by just doing that. Okay, now let's move. Okay, this is exercise. It will be there in your paper as the test. And then, okay, these are the exercises as well. Let's move. Oh, okay, we are done with Euclidean geometry, but let me just take some few minutes to just remind you guys with some of the important parts that you will always use even in the future mathematical parts. What is that part of maths is fun? Oh, I can just use this space. So guys, wherever you have parallel lines, that is where you are allowed to use the reasoning corresponding angles, alternate angles, the co-interior angles, only if there are some parallel lines, A, B, C, D. In this case, this angle will be equal to that angle. What is the reason behind this? Because they form something like F. It is corresponding angles. Why? Because AB is parallel to CD. And let me use a different color. Now I will say this angle plus that angle. Now they are inside my U. They're at the corners of my U. These ones are not equal, but they are supplementary. What does supplementary mean? They add up to 180 degrees. Okay. And then we are going to have the third one, which is something like that. This one here is going to be equal to that one. They form something like Z. The reason behind this is alternate angles. Then you state your parallel lines that AB is parallel to CD. That's what you guys have to know. And you always have to state the parallel lines. As long as you used those three reasoning corresponding angles, alternate angles, and co-interior angles, you also have to state the parallel lines that you are talking about in there. And then what else can I now emphasize? Okay, is this a terminology for bisect? Bisect, we have bisect, we have intersect, we have perpendicular, which is denoted as something like this. This will be perpendicular, and then what else? It's bisect, intersect, perpendicular. Okay, bisect means cut something into two equal parts. Then intersect, they are just cutting each other in anyhow. They're just cutting, but that is intersection point there. Okay, and then you have got a perpendicular. Perpendicular means now where they cut each other there, the angle there is a right angle. Remember, we said a right angle is an angle that is exactly equals to a 90 degrees. We said the angle that is less than 90 degrees but greater than 0, it will be acute angle. And the angle that is greater than 90 but less than 180 degrees is going to be obtuse angle. And the angle that is greater than 180 degrees but less than 360 is reflex angle. And the angles around the point, or just the angle that is rotating from this point and all the way back to that point, is a revolution or angle around the point. Otherwise, let's end here for this lesson, guys. I will now see you maybe in the next topic or in the next grade. Thank you, guys.